Okay, I'm looking at two variables, driving speed and gas mileage for mid-sized cars. Now I've collected some data. The driving speed I'm going to let be the variable x, and gasoline mileage I'm going to let y be the variable. And I want to determine if there's a relationship between these two variables. So the first thing I want to do is go ahead and graph them. If you look at the data set there, for example, the very first one, at a driving speed of 30 miles an hour, the gasoline mileage is 28 miles per gallon. The second data point, when you run a mid-sized car at 50 miles an hour, the driving speed is 50, the gasoline mileage is 25 miles per gallon, and etc. What I'm going to do first is just to go ahead and graph these points in an XY coordinate system. I've set up the coordinate system there. I looked at the x-axis and associating the values to the x-axis that I have there in my data list. I have to get as high as 60. So I decided to calibrate the x-axis in units of 10 to do that. And the y-axis for the mileage data, I have to get as high as 35. So in that axis, I decided to go by 5s. 5, 10, 15, 20, all the way up to 35. Now I want to plot the points. The first point there, 30 miles per hour gets 28 miles per gallon. So I'm going to plot that point at 30, 28 is about right there. 50, 25 is about right there. Now go ahead and plot the other ones here very quickly. Okay, you can see the data points there. It does seem to be a relationship between how fast you're driving the car and what kind of gasoline mileage you're getting. The faster you drive the car, the less and less gas mileage. It looks like there may be a negative, fairly strong linear relationship is my guess. A negative linear relationship. Now, what we're going to do next is calculate the sample covariance and then the correlation coefficient. By looking at these two formulas, the covariance is going to have us do some calculations with the individual data points, both with the x's and the y's and their averages, and the sample size. It looks like we have 10 data points there, so n would be 10. For the correlation coefficient, I'm going to need the covariance, but I'm dividing by the standard deviation of the x values and the standard deviation of the y values. I think the first thing I'll do is to get the x bar, the average of the x's, the y bar, the average of the y's, and then the standard deviations of each set. So I'm going to get a calculator. I could also use Excel to do this. Turns out my calculator says that the average of the x's is 42 and the standard deviation is 13.58. I'm using a sample standard deviation since we're considering these data points from a sample. The average of the y values is 27 and the standard deviation is, again, the sample standard deviation, 4.269. Now looking again at these formulas, I'm going to have to calculate some differences and then multiply them. So I'm going to create some columns here. The x sub I minus the x bar, I'll have to figure out what those are. And then I'm going to need the y sub I minus the y bar. And then I'm going to have to multiply those two together. So I'll create a fifth column here, x sub I minus x bar times the fourth column, y sub I minus y bar. Okay, let's put these data values in. X bar is 42, so I'm going to take x sub I, subtract the 42. In the first case, that would be 30, subtract 42, and I would get a negative 12. So I'm taking the x sub I, subtract the x bar. The x bar is 42. The x sub I is 30. So 30 subtract 42 is negative 12. 50 subtract 42 is 8. 40 subtract 42 is negative 2. Now let me go ahead and put the rest of these in. Okay, finishing that, I want to go to my next column. I have to also find the individual y values, subtract the y bar, their average. So I've got 28 subtract 27, which would just be 1. 25 subtract 27, which would be negative 2. And the next one's 25 again, so that's negative 2 also when I subtract 27. So let me fill the rest of these in. Now I'm going to go ahead and multiply the third and fourth column. And that would be negative 12 times 1 is negative 12. 8 times negative 2 is negative 16. Negative 2 times negative 2 is positive 4. 13 times negative 4 is a negative 52. So let's go ahead and fill these in. And there we have those products. Now you'll notice the very first part of the covariance formula is the sum of these products. So if I add that column all together, I'm going to get a negative 475. So in my formula, the numerator, the sum of all those products, will be a negative 475. And again, I'm going to be dividing by the sample size, subtract 1, or 9, and I get a negative 52.78, and that's going to be my covariance. Okay, looking at the correlation coefficient is the covariance. So negative 52, I've already calculated that, 0.78 divided by the product of the standard deviations, and I calculated those early. The standard deviation of the x values is 13.58, and then I've got to multiply that by the standard deviation of the y values, 4.269, and being careful to divide that total product into the negative 52.78, I get a negative 0.91 as my correlation coefficient. And that suggests a strong negative linear relationship between these two variables, being speed and mileage. There is a strong negative linear correlation. As the speed of the car gets faster, the gasoline mileage goes down.